there is some sort of data virtualization responsibility as well. Few of those are productivity, distributed query optimization, physical and logical independence, governance, and data quality. We'll look at each of these separately. Now, if you see the productivity, now data virtualization actually adds lot of productivity into an enterprise. As I said before, the consumers doesn't need to know how to connect to that physical source and what formats they are and how to convert and all. That will be the responsibility of data virtualization, which actually increases productivity. So it increases the collaboration and it increases the prototyping. Say, for example, if you want to do kind of a quick prototype done to prove that particular analysis or that particular system or new way of looking at certain data, we could do it easily because it is not tedious task to connect those data sources. Now those connectivity to data sources are being already done. It is available now, nice interface to us. And secondly, it provides us uniform access. So when if the consumer is capable of accessing via ODBC, it is available. So it doesn't need to switch their connectivity for different sources. So you have new uniform access and you have multi-access. There could be any number of, if this data virtualization is scalable, any number of consumers could consume same data, say at the same time. So now you could see, as you could see in the diagram, you could see that there are certain combining the data is already done. There's union, there's a intersection. So likewise, you combine data and get the views out. Data distributed query optimization is also one of the responsibilities. So when we combine this data, you could see that complex queries would build up. Now there could be certain ways of implementing that particular combination. As you could see, there are some strategies, there are some, you need to worry about the sources and the order of information that you require. Depends on that, there could be different plans, execution plans. So that would be chosen by this particular data virtualization layer. So further to that, the actual query could run push to the data source itself because it would be faster then, and as well as there could be kind of materialization where the preloaded, we can frequently use data could be preloaded into the data virtualization layer where it doesn't need to access all the time that data, but it would have kind of a expiration as well, so it's temporal locality. So those are the features that could actually increase the performance and it would optimize the query as well. One other responsibility of the data virtualization layer is that physical and logical independence. So for example, when you take ESB, it is good at orchestrating business services where the business services could be combined and provide some sort of linking those together to get something done. For example, workflow. In a workflow, there you might need to connect to different systems to get your work done, which is facilitated by ESB. Whereas data virtualization layer is good at accessing information repositories and homogeneous them and turn them into services. So if you combine these two, there you get some data sources combined together and get some information views out to this service orchestration layer. You could get a lot of things done at the business level. So that is where you logically independent the data. So maybe data located in physically in different places, but now it could be logically accessed, logically available. It doesn't need to worry about how physically located, how what are the formats of those data is. So there's an independence here. So that is the logical and physical independence. So in the data sources level, it could do its best way of keeping that data, and at the application level or consumer level or ESP level, it is independent of that physical um, constraints, and it could access data in logically. So, and the other responsibility is governance. So this is also very important. You should govern your information to make it more useful for the organization. One point is single point for data auditing, data and metadata, impact management based on source, and data monitoring. So these are the key features in data governance. You should audit, you should maintain, monitor your data, whether it is in accurate form. And security. So even though you have the access, and access would be controlled. So you cannot directly access your sources, but you can access through virtualization layer where the security is tightly controlled. Even though you don't you might have uh, might do some level of complex security management in each of the sources, but it is not actually what's happening normally in data warehouse data in enterprises in data sources. So it is complicated subject how to provide security for different stakeholders in different ways. So if we try to implement that in each and every source, it's very difficult, but that could be done in data virtualization layer. And you could protect data sources having query limits. So you cannot, if you expose your data source to all the applications, all the consumers in the enterprise, so they might fire or the queries at the same time to the data source where source would not be able to handle it. But the virtualization would manage that by limiting the queries and caching capabilities, and some sort of limitations in replication as well. Data quality also one of the important factor in an organization. So you could as a good practice in an organization, you need to have good data quality where accuracy, legitimacy, and validity, reliability, timeliness, completeness, availability, those things we have to be maintained with the data, and granularity as well. So to make sure these features are available with the data, we could have kind of testing here done at each level to see whether, for example, accuracy is there. You might get some data duplicated sometimes, right? Now when you access that data, you could see uh, where you get the latest information. So you can validate at that level and make sure that is the you consumer get the latest data out. So and there could be some logging and monitoring done on this. So the correct, so we could identify that sort of behaviors and we could correct them. So data virtualization is actually providing some sort of way of running the whole business It is not that we pass some data across here and there and get the things done, but it is running of the whole business. So we have to make sure that we get the required information out from data sources where data virtualization would help. And finally, this is the architecture. It looks like complex, yeah, it is some sort of, but that complexity is taken out from the data sources and the consumers into single place, and we could easily manage and combine data, provide better efficiency. Similarly, there are some additional features comes out from data virtualization. So for example, data virtualization saves data warehouse. Now this data virtualization also would act as a, uh, act a supporting role to data warehouse as well. Now, for example, federate where join across different data sources can be done in data virtualization level, and relief where get new requirements faster. Near real-time data analytics could be done on top of data virtualization, and prototyping, as I said, it is faster way of prototyping on top of um, data virtualization. And substitute when data warehouse is not available, so data virtualization would be a good place to get your information out and populate. Efficient method of accessing challenging data sources is where data warehouse would really help in getting this done. So there are some references that I refer to get this series done.